Today, as we begin chapter 9, we're going to talk about some types of variation. This is ways that variables relate to each other. That's what we mean when we say variation, is ways that variables relate to each other. We're going to start with two types. Direct variation is actually something that was covered a long time ago this year, but we're going to pretend like it wasn't because it's been a long, long time since we've talked about it. The idea of direct variation is a multiplication relationship. That y is some constant that we call k times x, so that our output is always the same multiple of times as big as the input. So if x is 2 and our constant is doubling, then y would be 4. If x is 8, then y would be 16. So that our output is always maybe 2 times as big or 3 times as big or half as big, but some multiplier times as big as the input. An inverse variation is a division relationship where x is in the denominator. That's really important, that in inverse, x has to be on the bottom. If x is on the top, it is not an inverse relationship. So our first type of problems today are just going to be to determine whether it is a direct or an inverse, or whether it's neither one of those, and that's okay too. So a direct relationship is a multiplication relationship. An inverse is a division. To see what pattern it follows, we need the y to be alone. So these are some unfortunate bullet points. They're not negatives. It's just PowerPoint turns bullet points into negative-looking things. So in the first one, if I want to solve for y, what do I need to do? Multiply both sides by 5. So I get that y is equal to 5x. Is that direct, inverse, or neither? Direct. It's a multiplication relationship. In the second one, y is already solved for. Is it direct, inverse, or neither? It's neither one of them. Addition and subtraction are not a special sort of variation for us. When we talk about variation, we're talking about a multiplication or a division relationship. The third one, we need to get y alone. What do we need to do that? Divide by x. So we get y is equal to 4 over x, and would that be direct, inverse, or neither? Inverse, because it's division with x on the bottom. And that's really important to note that distinction. That's a common mistake for students. Let's say, for example, as a side note, I had an equation that was something like y equals 5 over x. Is that direct, inverse? Did I say 5 over x? What I wrote is what I mean. If I had the equation of y equals x over 5, is that direct, inverse, or neither? I've heard all three answers, so let's break it down. Somebody who thinks inverse, why? It's division. Somebody who disagrees, what's the problem?
X is in the denominator.
X is in the numerator, and for inverse, it's supposed to be in the denominator. So that seems like a problem for inverse, but it is a division. Okay, so another thought.
Isn't that actually 1/5 times x?
We could rewrite this problem without changing its meaning as 1/5 times x. That's exactly the same thing as dividing by 5. So now when I write it in this format, is it direct, inverse, or neither? Direct. Okay? So make sure that if you have a division, that you confirm where that variable is. If that variable's on the top, it's really a multiplication by a fraction and it's direct. If the variable is on the bottom, that is inverse. Questions? Try these next three. Solve for y and determine which type of relationship it is, if any. For y, I need to divide both sides by x, and that leaves me with 4.8 divided by x. Direct, inverse, or neither? Inverse. Division with x in the denominator is inverse. For the second one, how do I solve for y? Multiply by 1.5. So I get y is equal to 1.5 times x. That would be direct in multiplication. And for the last one, if I solve for y, it would be done by adding, but adding and subtracting are not a special relationship for us. So that one will end up as neither. Questions? That's our first type of problem. In the second type of problem, we are told that our variables vary inversely. So this means they follow the pattern of y equals k divided by x, that inverse relationship that's defined at the top of your notes. And we're given a couple of values. That y is 8 and x is 3. We can use those values to find out what this k value is. We call it the constant of variation. Why k is a constant, I don't know, it's k, but it's k for constant. So we can use those values to find out what k is. And k would be 24. Multiplying both sides by 3 gives us a k value of 24. But we need to be careful when we answer our questions that we actually do what they tell us to do. Neither one of these questions asks us to find k specifically. The first one says, find an equation. Equation means it has an equal sign in it that relates x and y. So we want something with an equal sign in it that tells us how x and y are related to each other. That means it should have x and y in it. So our first answer is going to be the equation with x and y in it and k plugged in its spot. So when you are asked to find an equation that relates variables, those variables have to be there. Okay? So our first answer is not just what k is, but it's k plugged into its spot with x and y being x and y. That's part A. Part B says, now that we have this relationship, we can use it to find more answers. So what is y when x is -4? Y would be -6. So part B says, now using that relationship, plug in a new number and get a new answer. Okay. So first, we use the given values to find out what that constant is, that k value. But k itself is not an answer. An equation with k in the correct spot is an answer. Then use that equation, plugging in a new value to get a new answer. Questions? Go ahead and try this one. We're going to begin by looking at an inverse relationship which always follows the pattern of y equals k over x. Plugging in our starting values of y is 6 and x is 1.5, we can multiply both, we can multiply both sides by 1.5 to find that k is 9. But that's not an answer because it doesn't just say find k. It says find an equation that shows the relationship between x and y. So that relationship would be that y is 9 divided by x for any values of y and x. Then part B says, now that we have the relationship established, find a new answer. What about if we plug in 4/3 for x? What would we get for y? What's the same as dividing by a fraction? Multiplying by the reciprocal. So this is the same as 9 times 3/4, which would be 27 over 4, or you could give the decimal form of 6.75 as well. Questions? One more type of variation for us today is joint variation. Joint variation is like a direct variation, but it has more than one variable involved in it. So joint is a multiplication variation, but we also have an extra letter in there. Our first type of problem will be taking words and turning them into symbols. So we're going to start out by writing the first letter in the sentence. y. The word varies will mean equals. So whenever you see that word varies, that's our equals. And then it tells us the type of relationship. Direct is a multiplication relationship. So I want to multiply some constant times x. You will have a k in every one of our answers. That's our k constant times or divide or whatever type of relationship they tell us, but we will always have a constant. For the second one, y varies. So y equals, varies means equals. Inversely with. What type of a relationship is an inverse? A division relationship. And where does x go? On the bottom. So k divided by x. Okay? So inverse is a division relationship with our variable on the bottom. The next one, z varies. So this is going to start z equals. We always need a k, so you can just begin by writing the k and then figure out what type of variation you need. So y varies means I'm going to start with y equals. Direct is what kind of relationship? Multiplication with x, and inversely is division with the square of z, so z squared. You only need 1k per problem no matter how much other stuff is going on. So we don't need a k for each relationship, but just for the whole problem. So no matter how many different types of things it says go on, we can just have it all be rolled into 1k. For the next one, y varies, so it'll be y equals. Inversely, so that is a division with the cube of x. Again, not a root. The root will actually say the word root. A lot of students, when we say square of or cube of, want to make it a square root of or cube root of, but it will specifically say root if it should be root. The next one says z varies, so z equals. We always need a k. Jointly with, joint is a multiplication, and that will be with x squared and y.
Wait, just straight.
Yes.
No matter how you write that, could you put k y x squared or?
The order doesn't matter.
Okay.
Yep, so if you put the y first, that's fine. The last one, y varies. Inversely, so that's a division with both x and z, so those are both divided, they're both on the bottom. Questions on any of those? Our last type of problem is like the ones that we already did for inverse, but in these we're told we have a joint relationship. So the joint relationship means z equals kxy. And we're going to plug in the starting values. So z is 2. We don't know k. X is negative 12. And y is 4. Then we can solve for our constant, or k. So I can do that multiplication and get negative 48. And divide by the negative 48. And I get negative 1/24 is our k value. But that is not the answer to this question, because it doesn't say anywhere just find k. It says find an equation that relates z with x and y. So that means our answer should have z, x, and y in it. So equation with the k value plugged in its spot, just like it was in examples 3 and 4. Then for part B, it says, now let's plug in some new stuff. So find z when x is negative 4 and y is 7. We can multiply that together, and we get 28 over 24, which reduces to 7 over 6. Decimals would be okay as well. Okay, so first answer is an equation with our constant value solved for and plugged in. Z, X, and Y are still there. All our variables need to be variables. Then second answer, plug in some new values to get a new answer. Go ahead and try this last one. Laura, you do that. We're told we have a joint variation relationship, so that means our model is Z equals KXY. Plugging in the starting value, Z is 5. We don't know K. X is 1 and Y is 1/3. So we can solve for K by multiplying both sides by 3 and finding that K is 15. But that itself is not an answer. Our answer is the equation that gives a relationship between Z, X, and Y. Then once we have that relationship in part A, for part B, we can plug in some new values and solve for a new Z. And we get negative 420 when we do that multiplication. Questions? Tonight we are in section 9.1.